text-to-image generator, developed by OpenAI, which almost rivals the human mind in creativity. In this video, we'll look at what this system is, and how it works. Let's jump right in. DALL-E is a transformer language model text-to-image generator developed by the artificial intelligence company, OpenAI. A while ago, OpenAI released the world's most sophisticated text generator GPT-3, which is an AI with an uncanny ability to predict text. GPT-3 can converse with humans like a real human would do. The DALL-E system is the same, except it is smaller than the GPT-3 model, with 12 billion parameters and trained with image caption pairs. DALL-E is trained to generate images to given text prompts, using inputs of text-image pairs. This AI can create plausible images for a variety of natural language text prompts that explore the compositional structure of the given prompt. DALL-E has a diverse set of capabilities for an AI trained to generate images for a given text. It can generate anthropomorphized versions of animals and objects, combine unrelated concepts to generate abstract concepts, render text on objects in plausible ways, and transform existing images. Even though this is an AI, the DALL-E model's understanding of the real world allows it to generate images of real objects as well as the abstractions that we only see in our minds and paintings. It generates these concepts by transferring qualities from one concept to another, to achieve imaginary visuals, as we do with our minds. DALL-E is not only capable of generating full images, but also has the ability to edit the parts of the images it generated, to a given text prompt. When you look at how the system works, you'll find it harder than you think of. For example, imagine the following text prompt is fed to the AI model. An illustration of a baby radish in a cape walking a dog. To generate such an image, the DALL-E model has to first know what a radish and a dog is. Then it has to know where does the cape go, where to place the eyes on the radish, where should hands go, where to place the leash, while also considering the attributes and properties of each given element like color and shape. To compose an image of many elements, the DALL-E model has to have a great understanding of the relative positioning of each element as well as the placement of lighting, reflections, and the shadows. DALL-E is also capable of understanding phrases like close-ups and X-ray views, and can generate images in the most probable way. Generating images itself is an amazing feat, but to compose shadows, reflections, lighting, changing styles, changing locations and settings, and adding text to the images is an ability DALL-E achieved that even the developers didn't think of. While DALL-E is remarkable at flat image compositing, it also provides capabilities of 3D object rendering. It can independently control the attributes of a few objects and can understand how many objects there are and how to position them relative to another. Rendering settings like location, angle, and lighting are also taken into account when rendering. Unlike a 3D rendering engine, DALL-E does not need all the details to render a 3D object. It can fill in the blanks when a caption is lacking in details. Even though the DALL-E model is capable of such things, OpenAI pushed it even further by developing the next generation of the DALL-E model, the DALL-E 2 or Unclip. DALL-E 2 was launched approximately 1 year after the initial release of the DALL-E model. Even though this is the second version, the architecture of the system is completely different from its previous version. The new version functions the same as its previous version, but generates much more sophisticated and improved results. This new version is also capable of applying realistic manipulations to the generated images, such as adding new elements, removing existing elements with their shadows and reflections, or replacing existing elements with a natural language prompt. It can also generate different variations of a given image based around the characteristic of that image. DALL-E 2 got these abilities by learning the relationship between the images and the text that describe those images. Apart from the capabilities of the DALL-E 1, DALL-E 2 can do realistic editing to the existing images to a given caption, whether it applies to the whole image or to a part of it. Also, able to manipulate and rearrange objects in the images, proving it can identify objects in a flat 2D image like a human would. Since this is a video about the DALL-E 2 system, let's look at how the DALL-E 2 system works. Unlike DALL-E the original system, DALL-E 2 is not a single model. It's a combination of a few neural models, each capable of different tasks. DALL-E 2's image generation is broken into two stages, a prior stage that generates image embeddings to a given text prompt, using a clip model, and a decoder stage that generates images based on those image embeddings, with a diffusion model. Let's stop for a moment and understand these concepts. The clip model used in the prior stage of DALL-E 2 is a neural model trained to recognize objects in images, trained on images and captions pairs extracted from the internet. CLIP stands for Contrastive Language Image Pre-training. The CLIP model was first pre-trained to match images and their caption texts, then trained to guess the correct caption to a given image-text pair. Through this training, the CLIP system developed the capability to recognize any given element in a 2D image. The diffusion model, used in DALL-E 2's decoder stage, is a high-resolution image generator, which first generates the required pixels with a dark color and then adjusts the colors of the required pixels to generate the final image. Let's get a basic understanding of how the DALL-E 2 system generates images. In the prior model in DALL-E 2 system, it converts the given text into image embeddings using the CLIP model, which is a three-dimensional graph containing characteristics of the image that need to be generated. Then these generated image embeddings are fed into the diffusion decoder to generate the final image. However, DALL-E 2 is not yet perfect. It makes mistakes no human would ever do. For example, when given a prompt of a red cube on top of a blue cube, it had trouble generating an agreeable image. DALL-E 2 can make mistakes sometimes, but its abilities are almost at the safety threshold in some fields. If this technology went to the hand of the wrong person, the person would gain the power to fake almost anything. It surfaces safety concerns like images of fake situations, fake identifications, altered images of personal photos, and so on. A few years ago, we thought a machine with creativity was impossible to make. But today it has not only become a reality, it's also at a level where it rivals our unique ability of creativity. DALL-E 2 carries a lot of potential for future development. In the near future, it may gain the ability to generate animations to a given text prompt, a task we once thought was impossible for a machine. If a machine can come up with unique concepts as we do, does it mean that machines are slowly closing the gap? What do you think about this? Will AI get better than us in creativity? Let me know what you think. And see you another video.